The next speaker is David Scott. He's Professor and Vice Chair Research at Department of Medicine, Uniformed Sciences, University of Health Sciences at Bethesda. He has a very long and distinguished career. He's a very well-known cellular immunologist and has been known to dabble in the area of tolerance from time to time. So I think he's going to talk us through that. Before we start as well, I just reminded that everyone's meant to fill out a speaker evaluation form as well, please, before the end of today. Thanks.
You don't have to fill out my speaker evaluation. Thank you, Matt. So by way of full disclosure, I should point out that I am on the Scientific Advisory Board of Epavax, and you've heard a little bit about T regitropes, and I'm going to tell you a little bit more about it and perhaps put it in a little more context than Ethan Shebeck did yesterday. So my overview today is I'll talk very briefly about the nature of immunogenicity because we've heard about it throughout the meeting. Just a couple of points. I just want to make a couple of bullet points as it relates to tolerogenicity. I'll give an introduction for the non-immunologist about tolerance mechanisms, then talk about a variety of methods that have been used to induce tolerance to biotherapeutics and in experimental models, and try to go through a list and put some value judgment on that. And then finally, and that will lead into some talk about FC fusions. And then finally, we'll hopefully have an open discussion about the implications. So, as Michelle said earlier, there's a number of factors that can control immunogenicity, extrinsic as well as intrinsic. This is my list of the factors that control immunogenicity. And rather than reading this, I just want to point out that the important thing that we often forget about is the biologic properties of the product. You know, is it an antibody? What is it against? Is it against the cell surface molecule? Or does it have any intrinsic enzymatic activity that could infect it? At great risk, knowing that Pete Lawler is in the audience, I'm going to talk about factor VIII, and that will be one focus of the talk in terms of tolerance. As you all know, hemophilia patients have mutations in factor VIII, which can affect their ability, that affects their clotting ability, the procoagulant activity. But factor VIII is actually a highly immunogenic molecule itself. And I think this is due in part to the fact that it plays a major role in procoagulant activity and generates thrombin. And what we've shown basically about a year or two ago is that if you block thrombin activation, you can block the immunogenicity of factor VIII. So when you're thinking about a product, you may want to think, you don't obviously want to knock out the ability of factor VIII to be a procoagulant protein, but you obviously also need to think that could affect it being more immunogenic in some individuals. So that's the only point I wanted to make about that. What about modifying T-cell epitopes? Matt Baker is going to talk very soon about deimmunization. Obviously, Epavax is also in the business of deimmunizing proteins, and you've heard about changing epitopes that would bind to MHC, and that could clearly affect immunogenicity. Same thing with tolerogenicity. One has to have epitopes that can bind to MHC in order to turn off T cells or turn on T regs. So I think that this is something one has to think about. I put this